All right, have you ever looked at artificial intelligence and thought, that is just a magic black box? Well, today, we're going to pry that box open. We're going to demystify one of the most powerful tools inside, deep learning, and you'll see it all starts with one surprisingly simple idea. Okay, so let's dive right in. Let's look inside that black box. And yeah, at first glance, it's probably going to look just as complicated as you'd expect. I mean, if you've ever tried to figure out how deep learning actually works, you've probably slammed right into a wall of code that looks just like this. It's it's just a sea of variables and numbers. Feels like a totally impenetrable black box, right? But what if I told you that all of this whole complex mess, is really just built from one single, incredibly simple idea? That's the secret we're going to uncover together. Okay, so to make sense of all that code, we have to start small. We've got to find its most basic, most fundamental building block. And it all starts with something you probably remember from high school math, believe it or not, the function. Just think of it like a simple machine, right? You put something in one end, the machine does one specific thing to it, and something new pops out the other end. Simple as that. So, for example, a square function is super simple. You put in a 2, it spits out a 4. You put in a 3, it spits out a 9. Easy. Then there's another one called ReLU. That's short for rectified linear unit, by the way. It's a huge deal in deep learning, mainly because it's so simple and fast. All it does is, if you give it a negative number, it turns it into 0. If the number's positive, it just leaves it alone. See? They're all just simple, totally predictable rules. Okay, but here's the real trick. Let's stop thinking about these as just, abstract math concepts. Instead, let's picture them as actual, physical building blocks. Think of them like Legos. Each Lego block does one simple job, represents one simple function. All right, so we've got our Lego pieces. Now what happens when we start snapping them together? Well, we can build a chain. You take the output from the first block and you feed it right into the second block. And just like that, we've built our very first super basic model. In the world of machine learning, a simple chain like this is what you'd use for something like a linear regression. Now, this is awesome for finding simple straight line patterns in data, but let's be real. How often is the world a perfect straight line, What happens when things get a little more messy? Okay, take a look at this. This is some data on housing prices. You can clearly see there's a pattern here, right? As one thing increases, the other one kind of swoops down. But it's definitely not a straight line. It's a curve. And our simple little chain of blocks, our straight line model, it's just not going to be able to capture this pattern. And boom, here's the problem in action. Our simple model, that straight line, it tries its best, but it just completely misses the curve. It fails to capture what's really going on in the data. So this tells us something really important. We need a better, more flexible way to put our Lego blocks together. And it was this exact limitation that led to a massive breakthrough, a much, much more powerful way of building models. And this is where the neural network finally enters the picture. So this is the big leap. A neural network, it's not a simple single-file chain anymore. Instead, it's a much more complex arrangement of those exact same building blocks we started with. And it's this new structure that gives it the power and flexibility to learn those tricky curved patterns we just saw. So, a neural network can do two really crucial things that our simple chain just couldn't. First, it can learn those nonlinear curvy relationships. And second, and this is a huge one, it can learn how different inputs, when combined, affect the final output. Okay, so now we have all the pieces on the table. With this in mind, we can finally go back and solve that first mystery. What exactly makes learning deep? So what is deep learning? Well, it's actually pretty straightforward. It's just stacking these neural networks on top of each other. We take our Lego creation and we just build it taller. We add more layers. And each new layer can learn more complex and more abstract patterns by building on the simpler patterns learned by the layers below it. It's like going from building a simple Lego car to building an entire Lego city. So remember this thing? That scary-looking code from the very beginning? Well, it's not a black box anymore, is it? Now you know exactly what it is. It's just a recipe, a set of instructions for assembling and training those simple building blocks we've been talking about this whole time, just on an absolutely massive scale. Seth Weidman, the author of the material we're looking at, he puts it perfectly. He says that even for the most complex looking models, the basic math and the way they're trained, it's all the same as for the simplest models. The core ideas, those building blocks, they never change.
And there you have it. We've taken that black box and turned it into a box of Legos. The big takeaway here is that deep learning really isn't magic. It's just math. It's logic. It's simple ideas assembled in really clever ways and then applied at a mind-boggling scale. And now you get the fundamental idea that's behind all of it.